Hello, thank you for coming to my presentation. My name is Haokai Zhou, and the topic of my presentation is developing an objective refereeing system for fencing and using post-estimation algorithms and expert knowledge to determine priority and ensure fairness. So first, I would like to briefly explain the rules of foil and saber fencing and the term of priority for those unfamiliar. So basically, in foil and saber fencing, in the case where both fencers hit at the same time, the whatever whoever has priority is the person who will receive the points. And as you can see, priority is determined by three factors: movement, blade contact, and intention. So movement is basically priority is whoever is attacking. So if one person is going forward and the other person is retreating, then the person moving forward is the one with priority. And blade contact is if I block your hit and then we both hit, the person who have just blocked will have will have the priority. However, for the last one, which is intention, is a bit more complex. And this usually involves the referee determining there's no specific rule in the rule book that justifies and explains this term. So often the referee has to make their own decision, and this is often based on the extension of the arm and whoever is starting their action first. Okay, so now I will move on to some problems that I see with current refereeing. So first, it is subjective. Because of the lack of clear explanations, often in the rulebook of fencing, and with words that are very loosely defined, every referee have their own interpretation of the rules. What this could lead to is fencers not really knowing how the referee gonna call certain actions and having to work around it by being not fencing how they would and testing out different things to see what the ref would say. Secondly, is inconsistent. So this is caused by referees uh, not knowing how they want to call things, and oftentimes in the middle of a bout even, they would change how they call certain actions, which could throw off the fencers even further and lead to them not fencing at their best. And lastly, not adhering to conventions. So oftentimes, a lot of refs who are from the older generation are not moving forward with the conventions of refereeing, and this could lead to further miscommunications and misunderstandings, as oftentimes these newer generation fencers are not used to the way that these older refs are calling it, and they're not used to the way that how they would need to fence in order to get the correct calls for them, which could lead to the fencers just not being able to fence how they would like to, and forcing fencers to fence a specific way. And oftentimes it will just have strange calls that no one really quite understands. And of course, mistakes always can happen. So that is for the referee side, but also for the second problem, the second sets of problems are for the event organizers. So firstly, it is expensive. Paying for lots of ref to come to your events, especially internationally, is very expensive to both pay for their food, the housing, the travel, salary, and all the other expenses. And the second problem is the lack of interest that's actually comes with the refs. Even though they get paid, but the salary will be very little compared to their normal job. And what this refereeing does is that they have to travel to a different country, to a different location, potentially a different country. That takes time away from their normal job, from their day job, and their family, and could potentially eat into their vacation time, which is not very interested by most people. And because you're unable to sustain yourself through being a fencing referee for your livelihood, you would have to get another job. So this is incredibly disturbing of your normal life. So not many refs want to come. Which this problem is solved by a certain level by my project, because you do not need to have as many human refs present, and you are able to rely on the system a lot more. So first I would like to explain a similar system to mine. So this is the Sony Haokai system. And basically, this is already widely used in professional sports and Olympics in sports like soccer, tennis, badminton. And what this does is it tracks objects and it creates a 360-degree visualization. This is extremely helpful in the reffing of other sports. As you can see from that picture on the left side, that will be almost impossible for a human ref to detect. But with the presence of technology like this, it is possible. So I wish to bring this to fencing and make the life of refs easier and make the life of athletes easier as well. So what is my approach? So my approach is that I combined the post estimation and expert knowledge. From the graph you can see on the right, that's an example of what we can do. We can correctly find all the key points and all the limbs of the human body. On the left side, I have had that, and the left side is how the expert knowledge is applied. So my main focus here is movement analysis, as I speak before, with intention, blade contact, and movement. I have chose to focus on the movement and intention part. So as you can see from the right, I will briefly explain my program. On the top will be the actual video that is chosen by the user and will run through the entire thing with the object with the body tracking on it. And the middle, the arrow you can see is the person who has priority. So for example, if the arrow is pointed left, the person on the right has priority, and if they both hit that, he will get the point, and vice versa. And on the bottom are some key statistics that are used to determine the points. I'll now explain them further. As I explained before, the human identification of keyboard matching is this, and then there's also critical statistics tracking, which the graphs, quantitative data, and thresholds that is actually used in finding the right of way by the AI. So this way is both visible to the system and to the ref, and to if there's a human ref present for the human ref and for the fencers if they wish to see how the decision is justified. And lastly, there's the arrow for specifying and visualizing priority for ease of use. So here is a demo. Oops, how can I play this video? Sorry about this. I'm having difficulty playing this video. I apologize. Is the AI-driven fencing referee. In this project, I wrote the code and created an application that is able to of full and saber fencing and produce a result for whichever person displaying as the priority. This is important fencing because in full and saber specifically, the person who has priority will get the touch when both fencers hit at the same time. And oftentimes, between referees and even for the same referee, they will make inconsistent or subjective calls. And the point of this application is to eliminate that while people will be able to use it in a training setting without the need for another person to referee. So a difficulty that I encountered along the way is selecting a model for detecting the actual fencers in the frame. So first I used YOLO v5 in conjunction with MediaPipe. However, with this, it was inaccurate, and because it had to use two models together, it took a long time to process. So my solution was changing to the newer YOLO v7 that was faster and produce more accurate results, however, required more setups. And I think I will incorporate the function of the detection of a blade, even though it is a small part of the actual detection and the results produced. I think it will increase the accuracy in actions that there is a blade action. So now I will show you a demo of how this works. So first, I just want to open that and browse. I will find the video file that I'm looking for. And you press open and submit. Now it worked. So you can view this video. Key statistics that will indicate and help the referee, as well as I will show how this algorithm makes the decision. So now the arrow indicates the person who has right away. So in the beginning, we see that the right fencer is moving forward, therefore is right away. But now we see that he is slowing down and stopping. And as the left fencer takes initiative, the right away changes the left fencer. And in the end, you can see that as they're moving, it indicates that the left fencer has initiative and has the priority, and which means under conditions that both hits, he will get the points. And if you want to just quit the program, just press exit. Okay, I will come back to my presentation. So what are some of the dependencies that my project is based on? So as I said before, of course, I'm using YOLO v7 for the actual object and body detection. However, it is also based on OpenCV for the general infrastructure, the frame, and the cutting of the videos into the frames for the analysis, for the specific analysis. So I have some user feedback, and I have experimented with the accuracy. So as you can see first with the user satisfaction chart, we have a high level of users who rank my program between 8 and 10. Even though there are some people who rank it lower. For example, there's about 19 people who rank it from being 6 to 8 and about 5 people from 4 to 6. I think that could be due to the bout that they have used, which could resulting in having a lesser accuracy, and also because maybe they didn't quite understand how the program is supposed to be used. And also for the accuracy, you can see we usually attain an accuracy of 80% to 100 on 77% of our bouts, and most of the majority of the rest was attained on the 60 to 80% accuracy, which is a very high accuracy. And as I said before, the occasions where the bouts where there are a smaller accuracy could be because there's a high level of blade contact that this program is not accounted for. However, most of the times you can see from the graph is not consequential of the results. So similar programs. So first, AlekGo. So AlekGo is a similar program. However, it is based fully on a neural network model that is trained on existing labeled videos in order to make a decision, meaning it is not using an accurate system and it is purely an algorithm. However, neural networks are opaque in the sense that their specific parameters are not visible to humans and can only be seen in terms of their weight in the decision-making process. Therefore, how the decisions are made are unable to be explained by the person. So when the model's decisions are questioned, the user cannot offer an answer to the reasoning behind the decision, which is often asked by fencing competitions. And due to the high stakes of the competitions, it can harm both the fairness and bring question to the result of the tournament if the model is used to judge it, especially in more controversial cases. And in my second one, this is a paper called How to Use Convolution Neural Networks to Build a Referee by Rui Guo. This is a similar project to AlekGo in the sense that they both took the approach of a fully neural network model based program. However, this is trained specifically on trained specifically on Saber, and it as well, and that says the same problem of AllyGo, and that can only be applied to Foil or Saber based on whatever program based on whatever videos they're trained on, and is able to switch like my program. So future developments. So in the future, as I said in the video, I would like to work on the blade detection, because even though this is a small part of fencing, it will be a big part of fully eliminating and removing the need of a human ref. And further, this could be applied. The program can be used at competitions with no human refs at all, or very little amount of refs that just in need of the setup. Conclusion. So why is my program needed, and why is it good? So first, fairness. This should guarantee the objectivity of a ref that a ref should have, and also eliminate the many accuracies of human referees that could cause just purely by misjudgments or the pressure to be a good ref under the pressure of competition. The ease of access. So this will be much cheaper for any event organizer to have than normal refs, no matter their size. And this can lower the entry for barrier for both event organizers and fencers who would like to go to more competitions, and this get more participants for fencing. Third is widely applicable. So not only could this be used in a competition setting, but the program could also be used in a training setting when fencers who does not always have a ref presence could use this to help them train. And lastly is my email. And do you guys have any questions?